In the world of DevOps, pipeline triggers are essential for automating the build and release processes. They ensure that code changes are automatically built, tested, and deployed without manual intervention. This not only speeds up the development cycle, but also reduces the risk of human error. In this presentation, we will delve into the various aspects of developing and implementing pipeline trigger rules, focusing on their importance, types, and best practices within the context of the AZ400 Designing and Implementing Microsoft DevOps Solutions course. Pipeline triggers play a crucial role in continuous integration and continuous deployment (CI/CD) pipelines. They help maintain code quality by ensuring that every change is automatically tested and validated. This leads to faster feedback loops, allowing developers to identify and fix issues early in the development process. Moreover, automated triggers reduce the need for manual interventions, thereby minimizing the chances of human error and increasing overall efficiency. There are several types of pipeline triggers that can be implemented in a CI/CD pipeline. The most common ones include 1. Continuous integration (CI) triggers. These triggers initiate a build whenever there is a change in the source code repository. 2. Scheduled triggers. These triggers initiate builds at specified times, allowing for regular testing and deployment. 3. Manual triggers. These require manual intervention to start the build process, often used for special cases or hotfixes. 4. External triggers. These are initiated by external events or systems such as webhooks or API calls. CI triggers are the backbone of any CI/CD pipeline. They automatically initiate a build whenever a change is detected in the source code repository. This ensures that every code change is immediately tested and validated, providing instant feedback to developers. CI triggers can be configured to monitor specific branches, allowing for more granular control over the build process. For example, you can set up CI triggers to only initiate builds for changes made to the main or develop branches, ensuring that only stable code is built and tested. Scheduled triggers are used to initiate builds at predefined times. This is particularly useful for running regular tests or deployments, such as nightly builds or weekly releases. Scheduled triggers can be configured to run at specific intervals, such as daily, weekly, or monthly. They ensure that the codebase is regularly tested and validated, even if there are no recent changes. This helps in identifying any issues that may have been missed during regular development activities and ensures that the codebase remains in a deployable state. Manual triggers require human intervention to start the build process. These are often used for special cases, such as deploying hotfixes or running tests on specific branches. Manual triggers provide flexibility and control, allowing developers to initiate builds when needed. They are particularly useful in scenarios where automated triggers may not be suitable, such as emergency fixes or one-off deployments. By using manual triggers, teams can ensure that critical changes are deployed quickly and efficiently without waiting for the next scheduled or automated build. External triggers are initiated by events or systems outside the CI/CD pipeline. These can include webhooks, API calls, or integrations with other tools and services. External triggers are useful for creating more dynamic and responsive pipelines as they allow builds to be initiated based on external events. For example, a webhook can be set up to trigger a build whenever a pull request is created or merged. This ensures that the pipeline is always in sync with external systems and can respond to changes in real time. Azure DevOps provides a robust set of tools for configuring pipeline triggers. To set up CI triggers, navigate to the pipeline settings and specify the branches to monitor. For scheduled triggers, define the desired schedule using cron expressions or predefined intervals. Manual triggers can be initiated from the Azure DevOps portal or via command line tools. External triggers can be configured using webhooks or API integrations. Azure DevOps also supports advanced trigger configurations, such as path filters and branch policies, allowing for more granular control over the build process. Implementing pipeline triggers effectively requires following best practices to ensure optimal performance and reliability. Some key best practices include: 1. Monitor specific branches. Configure triggers to monitor only the branches that require builds, reducing unnecessary builds and resource usage. 2. Use path filters. Use path filters to trigger builds only when specific files or directories are changed. 3. Implement branch policies. Enforce branch policies to ensure that only code meeting certain criteria is merged and built. 4. Regularly review and update triggers. Periodically review and update trigger configurations to adapt to changing project requirements. Implementing pipeline triggers can come with its own set of challenges. Some common issues include 1. Over-triggering. Too many builds being triggered, leading to resource exhaustion. Solution: use path filters and monitor specific branches. 2. Under-triggering. Important changes not triggering builds. Solution: regularly review trigger configurations and ensure all critical paths are monitored. 3. Complex configurations. Managing complex trigger rules can be challenging. Solution: simplify configurations and use templates for consistency. By addressing these challenges, teams can ensure that their pipeline triggers are efficient and reliable. Let's look at a case study of a successful implementation of pipeline triggers. A software development team was facing issues with long build times and frequent build failures. By implementing CI triggers, they ensured that every code change was automatically tested, reducing the number of build failures. Scheduled triggers were set up for nightly builds, ensuring that the codebase was regularly tested. Manual triggers were used for deploying hotfixes, providing flexibility and control. External triggers were integrated with their issue tracking system, ensuring that builds were initiated for critical issues. This comprehensive approach led to faster build times, fewer failures, and a more efficient development process. In conclusion, developing and implementing pipeline trigger rules is a critical aspect of any CI/CD pipeline. By understanding the different types of triggers and following best practices, teams can ensure that their pipelines are efficient, reliable, and responsive. The next steps involve applying these concepts to your own projects, regularly reviewing and updating trigger configurations, and continuously improving your pipeline processes. By doing so, you can achieve faster development cycles, higher code quality, and a more streamlined release process.